Greetings. I recently acquired a collection of Commodore Vic 20 parts, bits and pieces. The seller I got them from told me that he used to have more of this stuff, but he pretty much sold off, and I'm adding this, probably all the good parts. And here were the leftovers, and he would give me a good deal if I bought all of this, and that I could probably make one good one out of all of this. So of course, who am I to say no? And I picked up the whole load. So what you're seeing in the middle, we have 3 main boards, 2 of a later revision, which you can see from the shape of the board and from the power plug, which I'll get into later, and an early revision. They were all labeled, I think, well, this one says that it's a PAL system. This one said, I think it said memory problems, and this one said display chip problems on it. Alright, so we had 3 non-working boards, but let's go through the rest of the haul. I got a total of 4 power supplies, also in unknown condition, of course. I got a complete case and a keyboard. The keyboard was loose, it wasn't in the case. I've mounted it since, but the keyboard looked good and no broken keys on it, and well, you obviously need one of these. And then the big one was a 1541 drive, and this one's labeled Vic 1541. So it came out, so it's an early revision of the drive because they used the exact same drive for the Commodore 64s with a different label in front. Came with a manual for the drive, a serial cable that goes to the computer, and as I was taking the stuff to my car, it also has a disc in it. That's, I've cleaned up everything, and the disc was kind of dusty, so not a whole lot of hope for this disc. But what we're going to do today is instead of going through everything piece by piece and measuring voltages and all of that good stuff, I am pretty much done with this haul, and I will explain my toils and what the result is. So let's get started with the power supplies. All 4 of them here. They are rated at 5 volts DC and 9 volts AC. And they have this, what is this? This is a 7-pin DIN plug that brings power to the computer, even though only 4 of the plugs are used, 4 of the pins are used, 2 for the AC voltage and 2 for the DC voltage. Of these 4 supplies, 2 worked and 2 were dead. And there isn't a whole lot to show with these because all of these are potted. Now, what does that mean? And I think it's a good time to quote from the Wikipedia. And it says, quote, "In electronics, potting is the process of filling a complete electronic assembly with a solid or gelatinous compound. This is done in order to exclude water, moisture, or corrosive agents, to increase resistance to shocks and vibrations, or to prevent gaseous phenomena such as corona discharge in high-voltage assemblies. Potting has also been used to protect against reverse engineering or to protect parts of cryptography processing cards when such materials are used only on single components instead of entire assemblies. The process is, in that case, the process is referred to as encapsulation." So what does that mean? Well, there's reading the outputs of this thing, you don't even have to read up on it. It's pretty obvious. It's a linear supply with a 9-volt AC, with a transformer with a 9-volt AC secondary that's coming out on 2 pins, and then there's a bridge, a rectifier, and a cap, and a 5-volt regulator, and that comes out on the other 2 pins of this. Now all of these are encapsulated. How do I know? They're all, of course, the bottoms are glued in and held in place by the encapsulation material, so it gets really messy opening these up. And I'm not going to do it. I haven't done it on any of these. I did it a few years ago on a Commodore 64 supply, and it's messy. You got plastic flying everywhere, and and in the end, the case is it's destroyed. I'm not very good at taking these kinds of things apart. So what I did was I came up with a little trick, and that is using a really small drill bit, finding an inconspicuous place on the case, and drilling into it. Now, the plastic walls are really thin on this, so you know that the drill's going to go through those very quickly and emit a few black plastic particles. And then after that, it's either going to hit air, not emitting plastic particles or anything, or it's going to hit the potting material, so it's going to start emitting lightish colored stuff. All 4 of these are potted. So basically what I had left to do was plug them in and measure what was coming out on the power plug. 2 of them were good, and 2 of them were completely dead. Oh, and I forgot to mention, there's also a fuse in there, which is also potted. So you need to unpot this. You need to open it up and then unpot it somehow if you want to change the fuse. And, since I lucked out, I only need 2, one for the machine and one for the disk drive. I didn't want to go through the process of doing any of that, and so we leave them as is. There is also a rumor out there that some of these power supplies are called Vic killers, because what may happen under certain circumstances is that the voltage regulator shorts and outputs, I guess when you rectify 9 volts you get like 11, 12 volts DC, and if the regulator shorts, that's what's coming out the other end instead of 5 volts, and that will do a job and a half on your machine. So anyway, that was the first thing I did. I marked them so I know that I have 2 good power supplies. And now let's turn our attention to the PCBs. It's also interesting to note that functionally these all are or used to be the exact same, but I have 4, almost 4, kind of 4 different cases. These 2 are obviously different from the others. This one looks more like an Atari supply for Atari computers. These 2 are kind of similar. The case looks very similar, but they got different colored stickers on it. So these were all done at a different time. But, so these have the same part number. This one has a different part number, and this one doesn't have a part number. So it's they built these things for a long time, and whenever the bean counters figured out that they could save 7 cents on it, they came out with a new revision. So here's a look at the 2 of them. This one's nice and straight. Looks like everything is fine, but this one's dead. Nothing coming out. Probably the fuse is most likely blown in it. Worst case, the transformer is blown, but it's most likely the fuse that is deeply embedded impenetrable material. I think you'd have to take out the encapsulated circuit and bathe it in something really corrosive. And that doesn't harm electronics, but eats all of the material encapsulating it. But again, I don't need to do it. This one, I don't know how well it shows up, but it's bulged pretty good on the underneath. That doesn't really mean anything though, but in this case you can tell that this one's potted because it makes crackly noises. It's separated from the potting material, but you can't push it any further. So there's a solid block in here that contains all of the electronics. So I had to add some things to have to be able to test these, a monitor of course, and an AV cable. And the AV cable was pretty easy to build. It's kind of fiddly getting, soldering to 5-pin DIN plugs, but hey, it's a 5-pin DIN plug and it has video and audio, composite video and audio coming out of it. I started with this board, a later revision. And the reason I started with it was, to me, this looked like a gimme. If you look closely, every single chip is socketed on this board. But looking at it, that was not a factory job. I guess maybe somebody was servicing Vics, figured that it would be a good idea to have something with everything socketed. That way, it's the ultimate chip tester for a VIC-20 motherboard. However, it wasn't that easy. One of the things that goes bad very often is the VIC chip, which is a display chip over here, and these two mask ROMs, the basic and the kernel. So what I did first is, these are kind of funny because they're 8K by 8 ROMs, but they only have 24 pins. So in order to read these, you have to build an adapter, a 24-pin to 28-pin adapter that reroutes some of the signals so you can read the contents of this. And when I pulled the original, this ROM was good, this ROM was bad. It came back with FFs, and there was nothing on it. So, okay, good, I found something. I went through the other boards and pulled the basic ROMs. And the first ROM I pulled from the other boards was also bad, but the second one I pulled was good, which is this one. So I put this in here, and nothing. Black screen. So the other thing that dies is the VIC chip, but I could swap. The others had VIC chips too, but there was obviously something else wrong here, and it wouldn't have done me a whole lot of good swapping VIC chips. So I started measuring signals, and the first thing I noticed was that the 6502 CPU wasn't getting a reset signal. Okay, that was kind of easy to trace. I went to the source. They basically use a 555 in astable mode, so when you turn this on, just it sits here for a couple hundred milliseconds and then pulses the reset line from low to high to make sure, because the 6502 needs a reset pulse of a certain length. And in my mind, this is kind of overkill. What's wrong with using a resistor and a capacitor, but which most other people do. But anyway, this thing, the reset line wasn't coming up. So I checked it. I even, because I'm lazy, I just replaced the 555, but that didn't make things run either. And then I noticed, see, there's two wires here. If you look at the one that runs horizontally here, the red one, that was already in there. And I said, I wonder. So I investigated, and it looks like whenever this chip was removed originally, the trace was ripped, and it wasn't outputting to this resistor over here. So a fix had been made. Somebody already tried this when they were done, but it didn't work. And it's still, even with the new one, it wasn't generating a reset pulse. So I sat down and looked at it in a fine-tooth comb, and basically what happened here is that the trace, there's a pull-up resistor here, and this trace, basically underneath the socket, had been broken when the socket was removed. So the pull-up wasn't pulling up anything. I mean, you can see that they tapped the 5 volts down here, but this was supposed to pull up the output signal, and it wasn't. So the reset pulse never worked. So I added a jumper wire here, or bodge wire as people call it. What an ugly word, but I'm going to call it fly wire. But once I added this, the reset started working. The board wasn't working, but the reset was working. But the discovery of that, put me on the right path, because I said, hey, if there was a broken trace over here, and obviously since this never got fixed, I guess this board never worked after they socketed everything. That means there may be other defects on it that were caused when removing the socket. So I went through the long and arduous process of measuring connections, starting with the data and address bus over here and checking on the ROMs, and lo and behold, I did find there were two broken address lines and 1 broken data line that just they made it to the kernel chip, but they never made it to the basic or the basic ROM over here. What am I pointing at? And basically those signals then fanned out from here to the rest of the circuit. So you don't even need 2 address lines and 1 bad data line for it not to work. Any single one of those would have prevented this from working. But it wasn't a fast process, because every time I found a broken connection, I would jumper it with a fly wire, then hook it all up, hit the power switch, and nothing would happen. Finally, after hitting the 3rd one, it showed some signs of life, and this is what it looked like. Okay, boys and girls, I'm back. Sorry to make you wait, but it turned out that the monitor has a BNC connector for the composite video in, so it took me a while to find that connector. But yeah, let's see now if this thing comes up. So, yay, it works, jumping up and down. But did you notice that it took about 3 seconds from me turning on the power for it to boot? So that, I don't know why that pulse is so wide coming out of the 555. Well, I know why, because that's the resistor values they chose, but I don't know why they chose such a long reset on this thing. Well, they probably did a lot of field testing, and since there are a lot of MOS chips in here, which were somewhat unreliable. I mean, this thing's infested with MOS chips. They even started building their own TTL because I don't think they could get a supply of them, so they just build it themselves. But it works. Of course, I can't show the keyboard or anything right now, but we shall get to that. And time to look at the next board. Here's the next board. First thing I'm going to do is, obviously, since the basic ROM's missing here and the Vic chip, I'm going to transfer them over from the working board, and then we'll have a look at what was wrong with it. So long story short, I put these two chips in here, and it works. Now this did not work before. I got a screen full of garbage on it, but it works. So I'm trying to figure out how that is possible, and I think the mistake I made when I said that on the first board that the basic ROM was bad over here, I think I made a mistake. I think the basic ROM on this one was good, board number 1, but the Vic chip was bad. So when I put the Vic chip in from this one, when I took it out and socketed it and stuff, then that's after I did, of course, all the wiring problems, fixed all the wiring problems, then that fixed this board, the socketed one, for good. So what I think the problem with this was that the basic ROM was bad on it. And that's what fixed that. Otherwise it's in great shape. It did have a good Vic chip then. If I had just wanted to fix this board, it only needed a basic ROM, but of course I needed this chip to make the other board work. So we have two boards working, but this one, as you notice, is doing the same, like almost 3-second delay here before it boots up. It is identical to the other one. Now, notice it shows a large amount of memory free. And the reason for that is this has a total of 5K on board. It has 5K SRAM. Basically, two 6116s, which are 2K by 8s, and two 2114s, which are 1K by 4s. So you have a total of 5K on board, and you have 3,583 bytes left over, because the BIOS, or the operating system, or whatever you want to call it, uses up 1.5K. So at this point, as far as putting together a good one, I had two working boards, except they wouldn't work at the same time because I need two chips. I'm right now swapping these two chips between the two boards to make it work. But I got one good working board, so let's have a quick look at the last one. The third one is this board that was marked as being a PAL board, and this is an early revision. It's got the more solid construction with the heatsink and the cartridge shield and all of that in here, but the power input is like this split AC, these two split AC prongs. And not only does it have a barrier in the middle here, you can see that, also the pin spacing is non-standard. So if you get a normal two-prong connector, even ignoring the barrier in the middle for the moment, is they don't fit in here because the spacing on these are narrower spaced than those plugs are. So the way we're going to power this, and another thing is it's only got an 9-volt AC input. So this has a voltage regulator underneath this heatsink. This is generating the 5 volts here and a 5 volt regulator under here. It's regulating the 5 volts on board. So what I'm going to do is utilize the Variac over here and have it output 9 volts AC and clip that to the power input. Okay, so the board's hooked up. I need to put in the this also had a bad basic ROM, which I'm going to remove, the single working specimen I have. And I did verify that it was a PAL by looking at the part number on the Vic chip, the display chip, and it is a PAL part. So, but you should still be able to see I mean, if it's doing anything on the screen, even with an NTSC TV. So if we turn this one on, we get this. So this is almost acting like it has a bad character generator, which is this, but I tested this in the working board and the character generator is good. So this also has a different complement of RAM. It uses 2114s for the 5K. So it basically has 10 2114s to give you your 5K, but something else is obviously wrong with this. Now, one thing I found out, I've had this monitor for a while and I never realized that this is a dual mode monitor. It'll do NTSC and it's got a PAL button on here, so you can switch it to PAL. But all you get in PAL is it gets smaller and you get color. So it's pretty much the same thing. I spent some time trying to diagnose it, replaced all of the socketed chips, which some of them were. The 5 volts is fine, the voltage is fine, everything's great. We may have a RAM problem on this. 2114s are not the toughest chip in the world, but in order to do that, I'd have to start desoldering all of these and putting new ones in. But since I basically have 2 working boards already, and this is a PAL device anyway, so I don't even know if the Vic chip's okay. I mean, it's putting something up, but this chip may be bad, and you know, I don't think I'm going to pursue this much further. It does something. The address lines are good, data lines are good. It is active, but my main suspicion is still the SRAM over here. But we're going to leave that at we're going to leave it at that, and put together a good VIC-20 into the case, hook up the keyboard and all of that, and see if it in fact functions. I've decided to use board number 2 to go into the case and to make the complete VIC, because the other one, remember, is the one that has everything socketed. So in the future, when I have to repair other VIC-20 boards, that will be my tester, and this one will be the actual computer. Well, there it is in all of its non-existent beauty. Came together. It's solid, no stripped screw holes, and yes, the keyboard actually works, which is great. I went through all the keys, I went through every single key works, no hesitant keys, spacebar's good. So everything works fine here. So now let's look at the last item that came with this haul. Here's the last piece of the puzzle, the drive. But hey, I got a manual. There's actually a disc in here. What can go wrong? So anyway, this thing uses a regular power cord with an IC connector, so okay, that's expected behavior, i.e. the green light means it has power, and the red light means it is briefly activating the drive, and that should go out, as it did. These drives are this big and this heavy because the power supply for it, the disk controller board that goes through a serial cable, through a Commodore proprietary serial cable to the computer, and of course the drive itself are all housed in this thing. That's why it's a rather large piece of equipment. But what does this thing do? So what happens if I turn this on? Well, it briefly accesses the drive. There's no disk in there yet. And then it boots up. So far, so good. Let's insert the disk and see what happens. I mean, this is not going to try to boot off the disk. I know that much. It's like this the C64. It'll probably briefly activate the disk, but not really. I mean, it's just communicating, I guess, trying to see if the disk is present or not, and then just comes up as normal. So if we want to do anything, as I said, I have the manual, so nothing can go wrong. So first what we need to do is get a directory off the disk, and that works. You say load 8, no, that's wrong. Load $8. Dollar means directory, 8 is the unit number of the drive, because you can have several drives and they are started numbering at 8, I think. Searching, found something and loaded something. So it loaded, no, what am I doing? It loaded the actual directory, so, but it's basic, so I have to list it. Hello. Okay, so it's basically telling us what the program names are. Check disk. So what we got to do is say, well, first of all, clear, I guess, basic. Why did it go lowercase? Interesting. I better reboot it. And say load check disk from 8. Okay, so now it's supposed to have a basic program. Well, so far so good. It loaded the program. So I don't know what it's doing. I can hear the head move, and I don't see any error messages yet. So let's see what it says. Write protect on 18. Okay, so I guess it passed all the retests. Unfortunately, the disk is write protected. It was trying to write to this. I guess in order to go further with this, we would have to format the disk. Okay, I poked around a little bit. You know, when using two more sophisticated DOS programs, this one's, because it has so little memory. I mean, things are a bit strange on here, but I found a program that's called dir. So you have to load a program. Loads a basic program. And then you run it and you get a menu. So now you can actually check your directory. I think this is running at 110 baud or something. This is like, come on. But it shows you all of the good stuff that's on here. And then it gives you the menu again. Directory, quit program, and disk status. So let's see what the disk status said. Disk status says 0 OK 0 0. I guess that's good. And finally, quit program. So there you have it. The drive seems to work. The disk is a bit noisy. Probably should copy a few discs. I can't really load any games because all of the games I have on disk are C64 games. Every single one of those is going to require more than 3.5K of memory. And second, I don't have any cartridges for it, so I can't test the cartridge port, I can't test the graphics really. But I think if it comes up like this, the graphics would work. I'll just have to wait till I can find a cartridge. So I hope you enjoyed this. This was a good buy. The seller's prediction became true because he basically said you can make one good one out of all of this. And I did, with a few things left over. I have one more good power supply, one more good board. Maybe one day I'll get around to fixing the PAL board. Why, I don't really know, but yeah, I got everything I need to be able to claim a Commodore Vic 20 as part of my 8-bit computer collection. Thanks for watching. Please like and subscribe and hit the notification bell and leave me a comment. See you next time.